Hello everyone. So today we'll be reviewing the laws of indices. So the first law, the law of multiplication. When we are multiplying powers with the same base, we add the indices. Now let's look at this example. So the rule states that if the bases are the same, we can go ahead and add the indices. Now let's first identify our base. So our base would be 4 here and 4 here. And our indices, right, 2 and 3. Now, because our bases are the same, we can move on now and add the indices, right? So it would be 4 for our base, and then it would be 2 plus 3. And 2 plus 3 gives us what? 5. So our final answer would be 4 to the 5th power. Now we can check that answer to see if we're correct. 4 raised to the 2nd power means that we're going to multiply 4 2 times, right? Which is 4 times 4. 4 raised to the 3rd power right here means we're going to multiply 4 3 times, which is times 4 again, times 4, and times 4, right? Now what would be our final answer? Our final answer in this case would be our base, which is 4. And then let's count how much 4s we have. We have 1, 2, 3, 4, 5. So 4 to the 5th power. And we see where we get back the same answer. So as long as the bases are the same, we just go ahead and add the indices. Now let's work on another example. So the first thing you need to do when you're working these questions is to ask yourself, are the bases the same? Right? If you look at this example closely, you'll realize that there's a term here and a term here, right? The term consists of a variable and a coefficient, right? In cases like these, our variables represent our bases. So even though the coefficients are different, our bases are the same. So the rule applies. If the bases are similar, we can go ahead and add the indices. So rewrite our base, which is m, and then we'll go ahead to add our indices, which is 2 plus 4, right? But we can never forget about the coefficients that are there because they're part of the question. So what we need to do with these coefficients now is to multiply them. So we're going to multiply this 2 times this 3 right here. So it's going to be 2 multiplied by 3. And 2 multiplied by 3 gives us 6. So our answer for this question now would be 6m to the 6th power, as 4 plus 2 gives us 6. Now let's look at these last two examples. Now remember that the question to ask yourself is, are the bases similar? Now let's look at it. The base for this term here is Q, and the base for this one is R. Are the bases similar? No, they're different. So because of that, we cannot go ahead and add the indices. So we just have to write it back as is because we cannot add it, right? And you can put the multiplication sign. Same thing for this one. Remember that the 2 right here represents the coefficient. The base for here is m and the base for here is b. Again, the bases are different, so we cannot go ahead and add the indices. I hope you guys understand. Ready to look at the second law? The second law is the law of division. When we're dividing powers with the same base, the index in the denominator is subtracted from the index in the numerator. Now let's look at this example. Remember, the law of division states that if the bases are the same, then we subtract the index in the denominator from the index in the numerator. So let's work it out. So right here, we identify our bases as 5 here and 5 here, and our indices as 5 here and 3. Now, because the bases are the same, because they're both 5s, we're going to write our 5. And then we're going to subtract our indices, which is 5 minus 3. Now, 5 minus 3 gives us what? 2. So our final answer would be 5 to the second power. Now, we can work it out like this as well. So let's check our answer. So it's 5 to the 5th power divided by 5 to the 3rd power. Right here suggests that we're going to multiply 5 times. So that's 5 times 5 times 5 times 5 times 5 again. So that's 5 5s. Here suggests that we're going to multiply 5 3 times. So that's all over 5 times 5 times 5. Now we're going to cancel. So 1 5 here, 1 5 in the denominator cancels a 5 in the numerator. Another 5 cancels another 5. And another 5 cancels another 5. So what we are left with is 5 as our base. And let's count how much 5s we have left. We have 1, 2. So it's 5 to the 2nd power. And as we can see, we get back the same answer here as we had here. So as long as the bases are the same, we subtract the index of the denominator from the index of the numerator. Now let's look at example number 2. Remember that the law states that if the bases are similar, we can go ahead and subtract, right? So let's first identify if our bases are similar. So we have one term here and another term here. We have our indices here, which is our 4 and our 3. Now, we have what is called variables, and in front of variables are coefficients. And remember, we visited an example like that previously. So Q here and Q here represent our variables, and the variables are considered our bases. And our coefficients would be the number in front of our variables, which is 12 here and 3 here. So let's not mix up now coefficients with variables. So are the bases similar? Yes, they are similar because we have Q and Q. So we're going to go ahead and write our Q and subtract our indices, which is 4 minus 3. But we can never forget about our coefficients because they're part of the question. Remember, we identified our coefficients earlier to be 12 and 3. And the question says we're going to divide. So it's going to be 12 divided by 3. How many times can we get 3 out of 12? Yes, 4 times. So our final answer would be 4q to the 4 minus 3 gives us 1. But one thing that we need to know is that anything that is raised to the power of 1 results in itself. So if we raise q to the power of 1, we're going to get q. So this can also be written as 4q. And this would be our final answer. With these examples, the first thing that we have to do is to identify if the bases are similar. If the bases are the same, then we can go ahead and subtract. But if they're not, then there's nothing that we can do to simplify it. So let's look at this example. The base here is 2, and the base here is 3. Are these the same? No, they're not the same. So because of that, we cannot simplify this. So we have to write it back as is. Now let's look at this example now. Remember, if the bases are the same, we can go ahead and simplify. If not, we have to leave it as is. The base here is R and the base here is P. Well, let's look at the indices. The indices here is 3 and the indices here is 3. So even though the indices are the same, we have to focus on if the bases are similar. And the bases in this case are not the same. So we're not looking on the fact that the indices are the same. The bases are different, so there's nothing that we can do to simplify it. So we have to write it back as is. So here the answer would be r to the third power over p to the third power.